Hello, beautiful scientists. It's Miss Grady and
Hello, it's Miss Breland.
we are coming here to you to teach you about taxonomy. I hope you guys are doing well. I hope life is good. I know you're getting bored, but it's okay. You got some stuff to do in science. Breland. Yeah. Oh, your assignments for this week. There's 3, super quick, and you can do them. 1 is a dichotomous key activity. I'm actually going to show you with the help of Miss Breland, and Miss Breland's going to do the PowerPoint with you. But we're going to show you how to do the dichotomous key activity. There's 2, really easy. Legitimately, you can do this, and I believe in you. And then the 3rd activity is a lab, because I want you guys to get some practice actually applying it. So you're going to make your own dichotomous key. There are videos, YouTube videos on how to do all these activities. There are YouTube videos that help you through any of these things. Please reach out to me and Miss Breland. If you want to have a Zoom meeting like me and Miss Breland are having, please let us know and we'll set one up for you. If you need to have a conference because you don't understand something, please let us know. Please complete all your assignments. If you need assistance like computer or anything, let us know so we can get that set up for you. Breland, you got something to say?
Yeah, when you're on Teams, down at the bottom, there's a little video camera. If you click that, one of us will probably be online, or I can hear it from the living room, and I can come and see that you're asking a question, and I can video conference with you, so can Miss Grady. So I've done it multiple times last week with students. So you might not be able to see us, but you'll be able to see us, but we won't be able to see you. But we can hear what you're asking. So that's a good place to go as well.
Excellent. I was also going to say, please be getting your guided notes down, because if and when we come back and we take a quiz, don't you want to have your guided notes ready?
Yeah.
Yes, exactly. So please be doing your guided notes. Your guided notes are on the PowerPoint. They're literally going to be added. The PowerPoint's going to be added right under this video. And so please look at the PowerPoint, get your guided notes, do what we would do in class anyway, and also do your assignments. So Breland is going to go through the PowerPoint. I'm only going to chime in here and there, and she's just going to share with you what we have for this week. I have to learn how to share my screen. Oh, there we go. Okay. All right, Breland, it's your time.
All right. So the main thing that we're going to be talking about is classification. And the classification system is basically a way of kind of naming the items that the things that we are looking at, and figuring out how to basically what their names are and what categories they fit into. All right, so the importance of classifying our organisms is that we want to be able to put them in the correct category and classify them based on what they look like, what we're recognizing from them, and descriptors that come along with them. Basically, taxonomy is the science of naming and defining and classifying everything into a group. So that we can see their shared characteristics.
You already said
I basically just said that.
Perfect. Mm-hmm.
All right, so here we have something. What do you think it is? So more than likely, you're saying it's either a mountain lion, a puma, a cougar, or a panther. That's because they all look similar, correct? They're in the group Felis concorlo, and concorlo, Felis is feline, concorlo is the color. It's like a continuous color. And Miss Grady might have something else to add to that.
Oh, okay. So the reason why we use classification or classifying, the system of classifying, is because people might be out in the field and they look at this animal, right? And they're like, oh my God, is this a mountain lion? Is this a puma? Is this a cougar, a panther? And mountain lions are super common to a lot of areas, especially us in the deciduous forest. And so when we see this animal and people are like, all these scientists like, what is this? The best way to do it is to classify it with a unifying name. And so this animal, even though we probably see it as like a mountain lion, we actually give it the name Felis concolor. And the reason we do that is because we want there to be a universal name, as opposed to all of us having like different ideas of what this organism is. It's easier to just give it a name. And so now we know that it can be Felis concolor. And so none of us are like, is it a mountain lion? Is it a puma? Is it a cougar? When really it's just a mountain lion and we gave it this name. So that's why we classify organisms. Beautiful, Breland.
All right, so this little lovely looking guy with his nice hairdo, which is actually a wig, Carl Linnaeus, basically came up with a naming system. And I like to think about my old days in the media center. It's kind of like how they came up with, you know, when you're in the media center and you're looking for a book and you have it categorized based on fiction and nonfiction. That's basically what this guy did with all of our organisms. So you have binomial nomenclature. Bi means two. Y'all know that, right? So bi means two. So it's going to have two names, right? Nomenclature is basically the name. So you're going to have two names. The system was based on the similarities that we're seeing in the physical and structural characteristics of those organisms. So that's how he figured this out. And it does make it a lot easier. So.
Super easy. So at the time they couldn't look at the genes or the DNA. So they literally just had to look at organisms. The same way like you would look like at a group of jelly beans and start putting them in different categories just by their physical characteristics. That's what Linnaeus had to do, because they couldn't look at the genome of an organism and say like that, what did we say the other week? That gorillas had one difference in amino acids. He couldn't do that. So he had to use this physical characteristics, the phenotype of the organism.
All right, so here are the rules. There's always rules, you know. So there's 2-word naming system, and you want to make sure that you're using the scientific name. So that's what this binomial nomenclature is. The two rules are made up of 2 Latin or Latin-like terms. They have to be italicized or underlined. So if you're typing it on a computer, you're going to do it italicized. If you're writing it, you're going to underline. And then the first word is the genus, which is capitalized. And the second word is the species. So you got to know what a genus is, and you got to know what a species is, correct? You do. So what do you think? What do you think a genus is? And what do you think the species is? Genus is going to be your, sorry, my husband just made a noise, so I'm trying to figure out what he was doing. Phone just went off. A genus is the many species that go within. So a genus is the bigger category of the species. And Ms. Grady might say something a little bit more complex than me.
No, that's perfect.
I'm simple.
Yes. And then we have to say Homo sapiens, we've been talking about this whole year, is who?
Us.
Us. We are Homo sapiens. So we belong to the Homo genus, and our species is, so we know a lot of things belong to the Homo genus. So that is how we know for sure that we're in the same category as some organisms. All right, so really quick, the Linnaean system is actually usually seems a little daunting or a little big, but it's not, because we've actually been talking about this Linnaean system forever, and you actually learned this from 7th grade. So a couple ways to know this. We have huge categories, and I'm about to try and do it on the whiteboard in a second. You have basic levels or different forms. The biggest category that we all are gonna fall under is our domain. We'll talk about domains bigger when we get to like our 6th kingdom project. And then there's kingdoms. We belong to kingdom Animalia because we're animals. And then there's a phylum. We all belong to a phylum, a general phylum that we belong to. I'm about to show you the picture in a second of this girl. So our in our Linnaean system, our species is sapiens. So we are called sapiens. That is, we all look alike. We can interbreed. We can have the same characteristics. So we all look alike, and we can successfully interbreed. The bigger one is a group of similar species that have similar things that are closely related to each other. We cannot interbreed with anything that's in our genus. Our family is a group of similar genuses. They share similar characteristics. Think about your family. Though you may not be like directly connected to every single person, you still have characteristics that are similar to them. The order is the similar families. The class is the similar orders. Phylum, similar classes, and the kingdom is similar phyla in those divisions. And the biggest one, of course, is going to be our domain. So here's our perfect picture. Let me move Miss Breland a little bit. Breland, I'm gonna move you to the side, okay? So here, our biggest one is eukarya. Think about eukaryotic cells. We belong to the domain eukarya. It's gonna be our eukaryotic cells. Our kingdom is Animalia. Our phylum is Chordata. Class Mammalia. Order are primates. And then family are Homidea, and then we get smaller to Homo, and then Sapiens. So we're getting more and more and more specific. So from our domain, which is anything that has a eukaryotic cells, that means plants, animals, fungi, protista, all four of these belong into this domain eukarya. And then the kingdom gets it even smaller. It throws out all of the plants and fungi and protista. And then chordata is anything with the notochord, just like your spinal cord. You guys know what mammalia is, mammals. And then primates is our, like, any species that falls into the primates. You can think of primates, chimps, gorillas, any of those. And then hominidae is when we start to get into those, like, when we think about Neanderthals, those fit into those hominidea homo spaces. And then very specific, because we can interbreed, that's when we hit into the sapiens, our species. So that's how we break down each of the different levels. And you're going to do a project with this starting next week that you take an organism and you get it from the domain down to their species, just like we just did with this human. And I'm going to bring Breland back over. Okay, so systematics. So it's just so that we can name all these organisms. So because of their similarities in their structure, we can just put them in different groups. In a minute, you're going to do a project that shows you how you're going to group these different organisms. Did it have problems? Yes, it caused problems. Some groups look similar to each other. Think about like a lot of organisms that you guys see, like a tiger and a cheetah. They look similar, but they're actually, or tigers, that's not a good example. But organisms that are like distantly related to each other, or they look differently, but they're closely related to each other. A bird and a alligator is a perfect example of organisms that look different to each other, but they're so closely related to each other. So Linnaeus, smart man. We love him, but the issue is his stuff isn't perfect because of this. We no longer just look at the physical characteristics to group them. We actually look at their DNA. And we talked about in this last unit how important DNA is. I'm going to leave cladistics off. We will actually cover this next time you guys come to me. I'm going to teach you how to do cladistics and everything and teach you what a cladogram is. But today I really want you to go through dichotomous keys. And dichotomous keys are pretty awesome. I'm going to show you how to go through each of the dichotomous keys and show you how to decide what organism. So this is your first worksheet. Breland, can you see my worksheet?
Mm-mm.
You can't?
I cannot. I can only see the PowerPoint.
Perfect. I'm glad you said that so that I can fix this.
You'll have to change the screens.
I do. Let me go back to you.
Look at us learning how to do something.
Correct. Okay, now let me choose it. Okay. Can you see it now?
Yes.
Perfect. Okay, so this is what you do for dichotomous keys. I always start with the first organism. So here's our first organism. It's our dog. So you have to ask yourself every question along here to see what the actual scientific name is for your dog. So we're going to start with dog. Is the dog an animal or not an animal, Miss Breland?
Well, I do believe it's an animal. So
I'm going to go to what?
Go to number 2.
2. Does it have wings or no wings?
No wings, but it'd be kind of cool if it did.
It would. So what number are we going to?
We are going to number 6.
Does it live in water on land?
It lives on land, so we're going to number 7.
We're going to number 7. Has fluffy fur or no fluffy fur?
Has fluffy fur.
Perfect. So I'm going to go to
number 8.
Number 8. And then is it a common pet or not a common pet?
It's a common pet.
It's a common pet. So I'm going to go over here and I'm going to put Canaeus. Y'all better have this first one right. Familiaris. Okay. So that's what you do. So I'm going to do shark with you. And then I believe, because you are beautiful geniuses, that you'll be able to do the rest on your own. But that's how you do the dichotomous key. You literally just ask your question. So let me do it with Breland one more time. Breland, is a shark an animal or not an animal?
It's an animal.
Perfect. I'm going to go to
number 2.
Wings and no wings?
No wings.
No wings. Perfect. So I'm going to go to number 6. Lives in water or on land?
It lives in the water. Go
Perfect.
to number 9.
Go to 9. Has fins or no fins?
It has fins.
Has fins. So I'm going to go to
number 10.
Perfect. Razor sharp teeth or pegged pointy teeth?
Oh my God, it's got razor sharp teeth, right?
Beautiful. Breland is a genius.
Yeah.
Okay, I'm not going to. Okay, there we go. So, but I did something wrong when I did Canaeus familiaris. What did we say that Canaeus familiaris has to look like if it's a scientific name, Breland?
Well, let's refer back to our little PowerPoint.
Yes.
And the words have to be italicized.
Perfect.
If you're typing.
Yes. And then what else? There's one more issue.
That bottom one needs to be capitalized, but that's driving me nuts. But that's
bottom
not,
one?
That the bottom one has to be capitalized. That's
No,
because the bottom.
The top one has to be remember, the species has to be lowercase.
Right.
But our type A, because we're type A, we're like, no, make it capital. But yeah.
It's driving me crazy, but it's gotta be lowercase.
It's gonna drive you crazy. So if you guys have any questions about how to do the rest of it, all you do is ask your questions. So with the rows, you're gonna say animal, not animal. You're gonna keep going down. I believe in you. This is the funnest activity I actually like to do, because it's like a finding. It's a clues. You gotta find the clues. All right, let me.
It's a little puzzle.
It's a puzzle, a fun puzzle. In case it's raining on Thursday as well. We're filming this on Tuesday actually. So if it's still raining, fun activity for the house, right? Yay! Okay, here's the. I always want to do one animal one, and then I like to do a plant one, because plants are everything. Okay, so the first thing you're going to do, just like you did the other one, you're going to use the dichotomous key. So the first thing, luckily, Todd has to make an appearance because my battery is dying. 1 second, class. Todd, you're not going to help me? Oh no. He's playing video games. He's not assisting. Oh no.
I still go to work. This is my own time.
He's making a impromptu visit. Okay. We are about to be in business. There we go. Okay, so here is our leaves. So here we're gonna ask the same questions. Is it a compound leaf? A compound leaf is divided into leaflets. So there's gonna be different leaves. This is an example of a compound leaf. A single leaf is not divided into leaflets. Oh, Breland, can you see this leaf one?
No, I was going to tell you, I'm not seeing it.
Perfect. Let me do it so I can show you guys. Where's my leaves? Okay, here we go. We're trying to figure this thing out, guys. Same way y'all are trying to figure out this school learning thing. We're trying to. Here's our leaves. This is your second activity. Okay, you can see it now, Breland?
Yes.
Perfect. Okay, so here is compound leaves are divided into leaflets. So this is a compound leaf. It has leaflets. We can see the leaflets. Beautiful. A single leaf is not divided into leaflets. These are single leaves. This is a single leaf. This is a single leaf. but these are compound leaves because they have different leaflets. So you're gonna have to ask yourself, I like to start off with number 1. So here's number 1. Shoot. We're gonna say, is it a compound leaf divided into leaflets, or is it a single leaf? Breland, which one is it?
Sorry, I was texting.
Breland is like a student in class. Oh my gosh.
I'm texting.
Breland, is this a compound leaf or a single leaf?
It's a compound leaf.
Is it, Breland?
I don't know.
Oh no.
Actually, not. It's a single leaf.
Breland had to read it, guys. It's okay. So it's a single leaf. So I'm gonna go to number 4. Is there leaf veins? Are the veins branched from one single point? Which it is. I see that it's branched from a single point.
It is.
It is. So we're gonna, or is it, are the veins branched off a main vein in the middle? So is it coming from a single point or a place in the middle?
Place in the middle.
Place in the middle. So I'm gonna go to number 6. Appearance of leaf edge. The leaf edge is jagged, or is it untoothed, so not jagged. Is it jagged or not jagged?
It's jagged. It's jagged.
It's jagged. So I'm gonna put in our answer. Our answer is Butula, which is a birch. Just the same way we did the animals, okay? I'm gonna do one more as always. So we're gonna do number 2. Here he is. Now, Breland, are you ready?
Yes.
Is it a compound leaf or a single leaf? Simple.
It's like a single. I can't hear you.
Breland, it's a compound leaf because it's a leafless.
You know why? You know why? It's because there's 1, 2, 3, 4, 5, and you can rip the leaves off.
Yes. Thank you, Breland. You're such a genius.
I just like being wrong and then making it right.
Okay, so we're gonna go to number 2. The palmate range of leaflets. Leaflets will be attached at a central point, or are they just attached anywhere?
They're attached at a center point. I see.
Perfect.
It's right.
Beautiful. So we already know what our leaf is called. We're gonna fill that in for ourselves. It is gonna be called Easculus. If you can pronounce that, Aesculus.
Aesculus.
Beautiful. So that is this sheet. Easy peasy. All right, I'm going to stop sharing this sheet and I'm going to move on to the very last, which is your project, which is super cute. Let me find it. Oh, let me share because I have too much stuff open. Okay, 1 second, people.
I'm still texting, sorry.
Oh my gosh, Breland.
We have a meeting at 1 o'clock and everybody's asking me if I'm going.
Breland, you are going, aren't you?
Are you going to it?
Oh wait, we as a whole have a meeting?
I don't know. It's something with the school.
Oh, okay.
I don't know.
All right, we're back in action. Let me see if I can share it now. Oh no. Oh, here we go. Okay. All right, Breland, you can see my dichotomous key.
Yes, I can.
Okay, so you see how it says groups of 2? It's not, it's groups of 1. You're by yourself. I'm so sorry, you're so beautiful. Okay, but you're gonna do it in groups of 1. You don't have to worry about coloring your organism if you cannot print it out. I would like you to find colors for them. If you can go on, like, figure out a way to color it. I believe in you, if you could. If not, write what color they are and how their colors look. Here are your organisms. Okay, they're cute, right?
Yes, they are.
You gotta respect your babies that you're about to classify, okay? So here is our organisms. I have posted a video on how you should make a dichotomous key, but you're gonna make one, okay? So here's an example of how making a key. Clothing, go to 2. Not clothing, go to 3. How to set up, just the way you just did the other ones, you're gonna make your own dichotomous key on a separate sheet of paper. These are your animals. Make sure you give them names. I don't care what names you give them. Be creative. Now, on Teams, I have written in capital letters. This should be your own work. None, you and nobody else in any of our classes should have the same organisms. They shouldn't have the same names. They shouldn't have the same colors. It's your time to be creative. Have fun with it. and make sure that you follow this example guide to help you to get through this. So at the end of it, I should have names for all these organisms, and underneath here, you should have your dichotomous key. So let me enable editing so I can do what I want you to do. So underneath this, you should, ooh.
It just went away.
I know, it disrespected me.
Yeah, it did.
Let me share it back. Okay, so look, down here, you should have this down here that says, blah, blah, blah. So like, I have ears, ... Go to number 3. So you just do it like that. Basically, I have ears. So 1, I have ears. Go to number 3. Whatever you want to do it. However you want to do it. Impress me. Impress Breland. Have us like, oh my God, they're the most brilliant child ever. Each step identifies the organism or the object. Make sure that you choose groups, and each step choose one of the group steps, units of time, not more than 1 for each. Once your group is finished making a key, all organisms trade it. You can't trade it with another group because we're at home, sad face. But if you guys would like, we can definitely share it with each other. That's it for me and Miss Breland. Right, Breland?
That's right.
Okay, so your 3 activities. Dichotomous keys with animals, super easy. Breland, do we believe in them?
We do.
Breland did it beautifully. She showed you beautifully. 2, your leaf one. Literally, me and Breland did the first 2. You only have like 4 left. The third one is making your own dichotomous keys, making it interesting, making me and Miss Breland say, by the way, your virus projects last week were brilliant. Shout outs to, number 1, my very favorite one, Breland. And if you haven't seen it, please go look at it. Alexis Hall. Beautiful. It was beautiful. And a lot of y'all did do a lot of beautiful projects. I just remember that one being like, girl, I think she like glued stuff out, Breland. So wow me with this dichotomous key and get your shout out. There's a lot of other beautiful ones, by the way. You're all brilliant. But that one is the one I'm remembering the most. Breland, do you have anything else to say to our beautiful angels?
No, I just hope everybody's keeping safe and not going out. Because we don't want to get a virus.
We don't.
Nope.
Should be well. Do not get a virus. Have a good day. See you next week.